doing this morning? Great? Yeah, I hope so. I'm Julissa. I'm super excited and a little nervous because this is not only my first time in Miami, it's also my first time giving a talk in English. So bear with me if I mess up a word or two. I'll do my best. Thank you. Okay. I'm just really happy to be here and to share something that I like working with, combining React, Serverless, and Terraform to building full-stack applications without worrying too much about the infrastructure. So before we get into all the building blocks and cloudy magic, let me ask you something. Okay. Let's wait for the transition. Okay, raise your hand who here has worked with infrastructure before? Maybe setting up a backend, configuring a cloud provider, I don't know, like AWS, Azure, GCP, others, or just deploying a project somewhere. Okay. And who's found that process smooth and enjoyable every single time? Exactly. Scaling can be tricky, and it's one of those things you know matters, but when the app starts growing, they get messy and sometimes a little chaotic. Let me give you a clear picture. When we scale application, many of us encounter different challenges that can make the process complicated. If you have worked with growing applications, you might recognize this feeling. The things are starting to get a bit out of control, like our friend in this meme. So let's be more specific about these challenges. Which of these have you run personally into before? Number one, unexpected cost. When your AWS bill or the cloud provider that you use suddenly doubles or triples. Okay. Number two, performance issues. When your app starts getting slow as more users come in. And number three, complexity and maintenance. When you spend more time fixing than building. Oh, number four, all the above. Okay, it happened to most of us, and today I want to show you how we can make that less painful. So, when you're starting out, full stack development feels great. You build a React frontend, set up an API or two, maybe throw in a database, and it works. But when the app starts to gain traction, the real world hits with forwarding errors, wrong roles, timeouts, missing configs. Suddenly, you are switching between your current cloud provider, Stack Overflow, maybe in these days, ChatGPT, Claude, documentation, and asking yourself, why is this part so hard? That's the moment when infrastructure starts getting in the way. And as a developers, that's the last thing we want, right? So what if we could make it scalable, reliable, and actually simple, while staying focused on what really matters, building great user experiences, like our great application, yeah? So, well, it turns out we can. So that's where serverless comes in. Let me be clear, it's not a silver bullet, but it does take a big chunk of operational stress off our plate. With services like AWS Lambda, we don't worry about provisioning, patching, or scaling servers. We just write a function and it runs when it's needed. That means faster delivery, less backend friction, and more focus on the product itself. It's great for APIs, background jobs, file processing, and other use cases. And the best things, you only pay for when your code runs. Pair it with React on the front end, and suddenly building full-stack applications feels a lot more lightweight. And Another disclaimer could be serverless didn't solve all the problems, but it definitely made room for the developer to focus on the ones that actually matters. So far, we have talked about scalability and simplicity, but another huge benefit of this stack is decoupling. The front end built with React is completely separated from the backend to give us flexibility, better performance, and easier maintenance. And as a developer, we love decoupling, right? Okay, because it let us iterate quickly on the UI without breaking backend integrations or waiting deploys. So let me show you what that looks like in practice. Let's see if the video starts. Oh. Oh. Can you see the video? No? Maybe it's the internet. Give me a second. Technical issues. Okay. I think I can do this. Oh, okay. There you go. So this is a simplified architecture of the app that I am demoing today. And everything you see here is provisioned with Terraform. So we have users who interact with the front end built in React, hosted on S3, and globally distributed through CloudFront. When they interact, for example, submitting a form or fetching some stuff, the request goes to API gateway, which routes it to a Lambda function. That function can read and write to our DynamoDB or store and retrieve files from S3. Then return a response to the user. It's fully serverless, decoupled, and defined as code. Yeah, this stack is scalable, cost-effective, and most importantly, repeatable. Of course, another disclaimer, this isn't the answer to every problem, but it's a solid approach that's worked well in many real-world scenarios. The important things when we are talking about architecture, it's always analyze, evaluate, and choose based on what your project actually needs. Now, I have mentioned Terraform a couple of times, so to understand this better, we need to talk about the concept behind it, infrastructure as a code. So, what is that? Infrastructure as code is the idea that you manage your cloud resources in the same way you manage your application code, by writing files, dragging them in version controls, and letting tools like Terraform doing the heavy lifting. Instead of clicking through your current cloud provider, for example, the AWS console, you define your infrastructure in code, applying, and boom, it's live. You have all resources created in your cloud provider. This approach has changed how many teams manage their cloud resources, and in my experience, it's made infrastructure management much more predictable and less prone to human errors. EIC gives us some really powerful benefits. The first one is automate provisioning. So you are not setting resources by hand, clicking around in the console. Also, it uses declarative configuration, which means you define the desired state and the tool figure out the steps to get there. It's also version control, so you can track every change and roll back if needed, and collaborate like we'll do with app code. And it gives you reproducibility. No more wondering what changed between dev and prod, staging, or any environment that you have, because they both run on the exact same config. Terraform is one of the most widely adopted EIC tools, and it's built around 4 main concepts. The first one is the providers. They let you target a specific cloud platform, like AWS, GCP, Azure, or other one. And then we have the resources. These are the actual infrastructure pieces you want to create. I mean, defining a Lambda function, an S3 bucket, an API gateway, permissions, etc. The third one is the modules. Modules are reusable chunks of config, kind of like components in React. You define them once and reuse them across project. And finally, there is the state. This tracks what's been deployed, so Terraform knows what to add, change, or remove next time to run it. Let's look at a simple example. On the left, you can see I'm telling Terraform that I'll be using AWS as my cloud provider. In this case, I'm setting the region to US West 2, but you can change that based on your necessities. On the right, I'm defining a Lambda function. I give the name, set the runtime to Node.js, define the handler, and point to the code stored in S3. I also attach the role so the function has the right permissions to run. Then, when I run Terraform apply, Terraform compares what's already deployed with what's in my config and creates or updates wherever is needed. It's fast, repeatable, and remove all the guesswork we usually deal within the console, doing this manually. So maybe you're asking why Terraform specifically? Well, for me, it comes down to automation and confidence. It lets me spin up entire environments, from buckets to lambdas to permissions to cluster, etc., with a single command. Everything stays consistent across every environment, like dev, stage, and prod. And if I need to roll back something or apply a change, it's just a code update. And since it works with all major cloud providers, I'm not looked into one platform, which gives me flexibility as things grow. Let's break that down. Terraform automates your infrastructure, so you spend less time clicking around and more time building. That's the important thing. It creates consistent environments. No more it works on my machine, but not in staging, not in prod. It enables safe rollbacks and updates because everything is versioned, and it's cloud agnostic. So if your stack ever grows beyond your current cloud provider, you're already covered. Okay, so before we jump into the demo, I just want to highlight what this setup really matters, especially if you are working across both frontend and backend. First, you can spin your entire infrastructure with a single command, no manual setup, no clicking around in the console. Second, combining serverless with EIC. That means fewer config and way less guesswork. Teams just connect and work. And finally, your frontend can easily talk to your APIs, databases, or file storage with no complex configuration required. All right, enough of the slides. Let me show you how this actually works in action. This demo shows a simple Fullstack app deployed using Terraform, React on the frontend, and serverless backend, and everything defined as code. So let's see. Okay. Here's how everything comes together. We start by running a custom script. This script does 3 things. The first one, it applies the Terraform code, builds the React app, and uploads it to S3 all in one go. Terraform is now creating all the resources we need. That includes the S3 bucket for the front end, Lambda functions for the backend, API gateway for routes, AM roles for permissions, and also a DynamoDB table to store our data. It takes a few seconds, but that's okay, because doing this by hand will take a lot longer. The best part is everything is automated, and because it's written as code, we can track every change and repeat it whenever we want. So once Terraform finishes, as I configure in the outputs the API URL, it will show you. So we will use that on the front end to connect with the backend. And before opening the app, I ran a small script that adds some sample data to DynamoDB. This is a TCG card exchange for Pokemon built in React served from S3. So let's see a few Pokemons. Okay, so when I click in the refresh button, the app makes a fetch request to the backend. That request goes through API gateways, triggers a Lambda function. So we can see that in action. And yeah, it's a simple demo, I think. Yeah, so when I'm done, I can clean everything with one command, Terraform destroy. I also created a custom script to do a few steps additional. So that removes all the resources, the S3 bucket, the Lambda functions, and the routes, the database, the AM roles, etc. And that's the power of infrastructure as code. You can deploy fast, test, and tear everything down, all in simple and repeatable way. So, a few takeaways. The first one, yes, you can absolutely build a scalable full stack using React on the front end and serverless backend, like AWS Lambda, Google Cloud Functions, Azure Functions, or any other basis service for the existing cloud providers. The second, AIC code tools, whether it's Terraform, Pulumi, AWS SAM, CDK, or even OpenTofu, help you define, manage, and automate your cloud setup in a clean and repeatable way. And finally, by simplifying deployments and reducing human error, these tools give you more time to focus on what really matters and spend more time building amazing experience with React and shipping value faster. So, if you would like to explore more, you can scan this QR. It will take you to the blog post with all the resources and the presentations, the code, and few extra thoughts from this talk, like the challenge that we encounter when you start using serverless. Yeah, thank you all so much for your attention. If you would like to keep exploring this topic, find me on coreandev.com.